Welcome to the Explainer. All right, let's dive right into this masterclass on the Bombardier Q400. You can literally spot this aircraft from a mile away with that distinct high-wing design and those massive six-bladed propellers. So right out of the airplane operating manual, the DHC-8 Series 400 is a transport category airplane, and it requires exactly 2 pilots to fly it. It's powered by 2 Pratt & Whitney PW150A engines, and get this, they each generate a massive 5,071 shaft horsepower. It's approved for a maximum altitude of 25,000 feet, and depending on how the interior is set up, it can seat up to 90 passengers. To lock this foundational stuff in, I want you to use a really simple memory aid, high to 2590. That's high wing, 2 pilots, 25K altitude, and 90 passengers.
Okay, here's our roadmap. We are progressing in the exact sequence laid out in the manual. General specs, fuselage, flight panels, dimensions, structure, and finally the empennage. Just picture yourself doing a walkthrough, starting outside at the engines, stepping inside the cabin, walking up to the cockpit, stepping back outside to measure the plane, and then walking all the way back to the tail.
So, Section 1, General Specs and Weights. As we mentioned, it's powered by those 2 Pratt & Whitney turboprop engines. Now, to remember their exact power output, just use the trick 5071. That's 5,071 shaft horsepower pulling along each wing.
Now, what's really interesting here is the precise stepping of the 4 maximum takeoff weights. The airplane features 4 specific limits. It starts down at the basic gross weight at 61,700 pounds. Then it steps up to the intermediate gross weight at 63,930 pounds. Then the high gross weight at 64,500 pounds. And finally, it tops out at the enhanced high gross weight of 65,200 pounds. A fantastic way to remember these 4 weight categories in exact order is the acronym BIH, Basic, Intermediate, High, Enhanced.
You know, passenger comfort is actually engineered right into the airframe itself. The manual outlines that the airplane is equipped with an active noise and vibration suppression system, or ANVS, which is specifically there to quiet the cabin down during flight. If you ever need to recall what ANVS does, just remember this phrase: absolute no vibration sounds.
Moving right along to Section 2, the fuselage sections. Structurally, the main body of the aircraft is built in exactly 3 parts: forward, center, and aft. A really quick memory link for this is just to remember the 3 sections as FCA: forward, center, and aft. The crucial thing to grasp here is how access works with the doors. The forward section holds the flight compartment, obviously, but pay close attention to the compartments. Baggage doors open outwards and, critically, can only be opened from the outside. Meanwhile, the passenger compartment doors and the exit can be opened from either inside or outside. So your memory trick here is super simple. Baggage goes out only. Passengers go in and out. All right, Section 3, Flight Compartment and Panels. The forward flight compartment houses the vast majority of controls, instruments, and indications, mapping out highly specific stations for the crew. To keep from getting totally overwhelmed by that sheer sea of switches, you want to visually scan this space like a pilot. Remember this spatial scan: top for the overhead, front for the glare shield and instrument panels, middle for the center console, and then the sides. The manual actually maps out these cockpit controls in a very specific sequenced cascade. Starting way up at the overhead console, it moves down to the glare shield, then right to the main instrument panel directly in front, down to the center console between the pilots, and finally ending at the side panels and cabin attendant panels. Your acronym to lock in this sequence is OGICS. That's overhead, glare shield, instrument, center, side.
Section 4, Dimensions and Turning Radius. Let's step back outside the aircraft and look at its physical footprint. According to the manual, the aircraft has a wingspan of 93 feet 3 inches and a total length of 107 feet 9 inches. The wheel track is 28 feet 10 inches wide. And those massive propellers? They're 13 feet 6 inches in diameter, and they clear the fuselage by exactly 3 feet 7 inches. To keep those primary dimensions straight in your head, just remember, the span is in the 90s and the length is in the 100s.
Now, this is where it gets really cool when we look at the turning radius data and the sweeping path of those structural points. To perform a 180-degree turn using 70 degrees of nose steering, the aircraft requires a minimum of 84 feet 5 inches of pavement. And during that turn, the wingtip takes the absolute widest arc at 64 feet 9 inches. Your memory aid is right in the data itself. The wingtip makes the widest turn at 64 feet 9 inches.
Section 5. Structure, Wings, and Empennage. So, what is this thing actually made of? The airframe structure relies heavily on 4 key materials. High-strength aluminum alloys are used for the skins. Steel structural alloy is utilized in the landing gear. Magnesium is used in selected interior regions, and composite panels are used for parts like the radomes and fairings. The memory trick to retain these materials is just the word MAX. Magnesium for the interior, aluminum for the skin, composites for the fairings and radome, and steel for the gear. If we look right at the forward tip, there is a very strict division. The forward section consists of the unpressurized nose, which contains an equipment deck and the weather radar radome, and right behind that is the pressurized flight compartment, which is protected by laminated glass windshields. The simple way to memorize this division is the nose is open, meaning unpressurized, and the cockpit is closed, meaning pressurized. Okay, the wings. They're highly multifunctional. The manual states these are cantilevered wings, featuring a 2.5-degree upward dihedral taper outboard. They hold integral fuel tanks internally, utilize pneumatic de-ice boots on the leading edge, and feature single-slotted flaps, ailerons, and roll spoilers. And by the way, those spoilers also have a ground mode to reduce lift on landing. To easily recall all these wing features, use the acronym CDIFS. That stands for cantilevered, dihedral, integral tanks, flaps, ailerons, and spoilers. Check out the dramatic structural shift from the middle passenger area back to the tail section. The center section has a straight, constant cross-section with a slightly flattened bottom to accommodate the passenger floor. Meanwhile, the aft section is unpressurized, sharply swept up, and houses equipment like the air conditioning packs and the APU. Your memory link here is center equals flat and pressurized, aft equals swept and unpressurized. And finally, Section 6. The empennage. That towering T-tail empennage consists of a fixed incidence horizontal stabilizer, independently operable elevators with artificial feel, a vertical stabilizer, and rudders. Remember the 4 main components with the acronym HEVR: horizontal, elevators, vertical, rudder. This is brilliant engineering. The rudder system uses an ingenious double hinge design. It uses a tandem setup where the fore section of the rudder is hinged directly to the rear vertical spar. Then, the trailing section of the rudder is hinged to the back of that fore rudder. Thanks to its geometric arrangement and 2 actuators, the trailing section actually deflects twice as much as the fore section. Your trick to remember this mechanism is simply the phrase double deflection. The trailing edge literally bends twice as much as the middle. As we wrap up this explainer, I really want you to consider how these systems physically connect inside the airframe. Reflect on how understanding this exact sequential layout, starting all the way from the unpressurized nose and working back to that double-hinged rudder, creates true mastery of the aircraft's operations. The Q400 is an incredibly complex machine for sure, but if you master the sequence, you master the aircraft. So, which of these 6 structural zones are you going to prioritize studying first on your next walk-around?